All right. All right, we got some symmetry to talk about. So what is symmetry?
They're both the same.
Same on both sides, okay?
Kind of down the middle, both the same.
Yeah, like a mirror image and things like that, right? Okay. So what we're looking at here is our three different places for symmetry to happen. It could be symmetric about the y-axis, it could be symmetric about the x-axis, or it could be symmetric about the origin. The symmetry about the y-axis and symmetry about the origin, we're going to talk about again later, because this will be even functions and this will be odd functions. Right now, we have to create a test in order to determine these things. And so if you notice, and this should make sense, like if you're looking at something that's reflected across the y-axis, every point would be directly right to the left or right. And so if you notice what they're saying is, if you start with an xy, when you go and reflect it, that y isn't changing. We're still on that same level. But the x changes by the negative. Fair enough? Likewise, if we're saying that it's reflected across the x-axis, the x stays the same, right? We're just going up and down. It's the y that changes from a positive to a negative. Fair enough? Origin is a weird one. You're not used to thinking of something around a point. So like this is like the famous like one of being symmetric about the origin. And notice if it's true that your positive xy becomes negative xy. Is that okay?
Is that similar to like having a negative exponent where you have to flip both?
No, but I'm gonna do an example with you so you can see like what this does for us. Okay. So firstly, is that all this makes sense? Like why the x, why the x values, the sign of the x's change, why the sign of the y's change, and then if you can just accept that both change on this one.
Yes.
All right. So talking about functions. So what is a function? Well, okay, so then if the notation is, that's called f of x. What's it stand for? Y, okay.
Where you put into x would be y.
Okay, so then what's a function? All right, so yeah, so a function is an input and an output. Okay, that's what I want you guys to remember, input and output. So what's the inputs? These are usually the x values, right? Or they're always the x values. Usually they're called x. Then the output is what? Y value, okay. Now these have different names. Do you remember the different names of them? All right, well, we'll come back to that here in a second. Yeah, domain and range. Remember which one's which?
Domain is X and range is Y.
Yeah, okay, so then, right, so we are going to need to know all about that kind of stuff. But let's look at and right, that's f of x. Yeah, right, everyone, we already said that. And then this one would be what? And so why would there be an f of x and a g of x?
Because one's for the x and one's for the y.
Yeah, they're gonna graph two different ways.
But they're two different functions. Okay, so then the f and the g and the h and whatever, those are just names. Okay, so you can keep everything straight.
Okay.
Fair enough? All right, so then let's look at a pretty straightforward one. You guys got a couple things that you want to do today. So we'll do a very straightforward thing like this. Okay? So, firstly, I guess we should say is, if this is a function, this is a question. What is that question asking you?
If X is 0, what does Y equal?
Yeah, that's a perfect way to say it. If x is 0, what does y equal? Okay, and so then how do you determine that?
Plug in X 0 for X.
Plug in 0 any place you see x. All right? And so then I like the way she said it because this is a coordinate. Oops. This is a coordinate, right? So then that coordinate would actually be 0, 5. So I'll refer to this thing as the rule. occasionally. The first time you guys ever did a function, you're probably in, I'm guessing, 6th grade maybe.
Yeah.
Does that sound right?
Yeah.
How did you do it?
Oh, so there's that form.
You did not do slope intercept form the first time you graphed. First time you graphed, what did you do? You plotted points, right? So what you were doing was making a little XY chart, right?
Oh, 6 years ago, I don't remember.
All right, so if you don't have a graphing calculator, you should grab one right now. Always reset these because you never know what's going on. Go ahead to y equals, and you can put in what I have, 2x plus 5. And hopefully everyone knows what this looks like graphed. And some of this, like definitely if I had you last year, I'm sure I showed you this, but it's a good refresher anyway. This is a very powerful calculator. So you can go to graph and it'll look, right, it'll look something like, what? So when you graph it, it should look something like that, right?
Yeah.
Okay. Now you can always graph it, and so that's great. But now what I want to point out is if you go to second table, which is above the graph, it actually gives you all the coordinates. And so then it just is doing an XY chart for you, right?
Yeah.
All right. Now, if you notice the inputs on that, is everyone there? Right, the inputs are only integers. So that's super nice, except for sometimes integers aren't exactly what we want to plug in. So what you can do, and you're going to have to remember to do this because once someone else uses it, they're going to reset it and things like that. So if you look above, I think it's above trace. I think it's where it is. Table set. Is table set above there?
Table set is going down.
Okay, so go to the table set. So second table set. And then we have a very small menu, and it's independent and dependent. So let's go back to our inputs and outputs. Either the X or the Y depends on the other one. Which one depends on the other one? Y depends on X. So that makes X the independent variable. So if you notice, it says right now on independent, it says what? Auto. So if you scroll down and change auto to ask for the independent and hit enter, when you go back to the table, it should be completely empty. Is that right?
Yes.
All right. So why that is because you just said that I will tell you what I want you to plug in. And so now you can put in fractions, or you can put in decimals, or you can put in radicals, or you can put in whatever you want.
Is there a way to ask for y as one?
Because
I tried to, but I couldn't get it.
So that I've tried before and I gave up because I don't know. So I'm assuming no.
Would you
I don't know. I'm assuming yes because it says that you can change it to ask, but I've never been able to figure out how to do it.
Yeah, would you technically be doing just changing your dependent variable at that point?
Well, but then nothing happens. And so.
I spent a good 20 minutes on the quiz yesterday trying to figure out if I could get it.
Yeah, I don't know if it works. If you find out if it works, please let me know because I've always wondered, but I've given up on that. All right, so here's an overall goal that we need to understand that we're trying to do here. You want to know the shapes of these things, okay? So right now, this first one, right, 2x plus 5. Hopefully most people said, okay, A, it's a line. Probably I know where it goes through, right? It's going through 5 on the y-axis, and it's kind of a steep slope. So I don't need you to be super accurate, but when you look at that, is that some of the things that you think about? And if it's not, then it needs to start. Okay, this is the line. And I know that it's a positive slope and things like that. And you need to know what the positive slope looks like. Or if it's negative, what the negative slope looks like. Okay? So as we go on, you're really gonna, that's one of the things I want you to be able to do. Not an accurate graph in your head, but just generally what the shape is doing, okay? So what that means is pretty much you need to be in this calculator often. Does that make sense? There you go. All right, so going back to this graph, talking about functions, how do we know that this is a function anyway? By looking at the graph.
Line is straight.
That's not y as a function.
It has an X and a Y value.
It has an x and a y value, but
The parallel line test.
that's not what it's called, but the, what is it? It's not the, it's the something test. It's not the parallel line test. What is it?
Perpendicular line, I don't know.
It's the vertical line test, right? This passes the vertical line test because every x value can only have one y value. Okay, so that's a definition of a function also. All right, so are we okay so far? All right, so let's look at, let's jump up to part of the assignment, which is on page
115.
115, 114, 115. Come on. There is, all right. So let's just do number one. What is number one?
Y equals square root of s plus 4.
And then next to that, they gave us 2 points. What are they?
0, 2.
And
3.
Oh, that's
gonna be easy with our calculator.
So it could be easy with the calculator. So, yeah, so like this is your option, right? You can totally put in these to y equal every single time. Check the table, there you go. But they're asking us, are these points on this function? So how do you know if they are or not?
Just plug them in.
So you're just plugging them in. So what am I doing with 0, 2 then?
Just plug in a 0.
All right, so then we're saying, okay, y equals the square root of 0 plus 4.
And see if you get 2 out of it.
And then, so then that would be the square root of 4,
2.
which is 2. So then, yes, this one is on that curve. Is that okay?
Try 5.
All right, so let's do the 5. So then y equals the square root of 5 plus 4,
Equals 9.
which is the square root of 9. And that equals the 3. So now we should be happy. Right? Both are on there.
Yes.
Good stuff?
Yep. So then you just say, like, yes. Like, what would you do for number 1?
I just circle.
Yeah, I mean, like, you need to know if they are right.
I'm gonna just write down.
If you want to write yes, then good. If you're into brevity, you can just write y.
I'm just gonna write down correct.
If you want to be, you can use a thesaurus to find any other word that means yes. Yeah, it's a thing,
I know it's a thing.
right? If you want, you can do it in Spanish or German.
See. I don't know German.
I think it's just ja, isn't it? Yeah.
Ask the person who speaks German before I don't know.
So it's really up to you. I give you a lot of leeway in here.
Okay. Might do it with French.
Sure. We. Yeah. All right. All right. So is that first section okay?
Yeah.
All right. So then if you look at the next section, 9 to 12, right, it's saying plug all these in. Now I told the last class, another thing that we're trying to accomplish in this class is to speed you up a little bit. Okay? You guys have been allowed to take a lot of time on tests and things. But as I told the other class, yeah, your grades actually mean nothing to colleges. I don't know if you understand that or not, but it matters a little bit. Like if you got an F, they're kind of like, whoa, what's happening? But your A's actually mean nothing because everybody and their brother has an A. Okay? So having said that, what's important to you is the ACT, because then they actually can tell what you kind of got going on. On the ACT, as you guys will find out this year, if you haven't done it already, is that you have 60 questions and you get 60 minutes to do them. So you don't have time to be playing games, you got to get through it, okay? So another one of our goals this year is to get you guys sped up a little bit. And if you were looking at 9 to 12, right, all of them have 5 things. You are totally more than welcome to plug all 5 of those in and get the Y answer, right? This is just an XY chart apparently laying down. But you could also go to y equals, plug it in, go to the table, and there all 5 of them sit, okay? So again, the calculator gives you a lot of information and it makes you very efficient. Because what we're not doing this year is spending time like, oh, well, I mean, we may, I mean, it might be an issue, but, right, we are past the point of working on, oh, you gotta watch for your sign, oh, you gotta like, you know, you're not squaring right, like that's something that we need to make sure we can do, but you need to get the right answer and get information in your hand so that you can use it, okay? Because that's one of the reasons we do a lot of word problems. So far, so good. All right, the next thing we gotta talk about, again, we're just plugging things in and things are coming out, right? We're getting some functions, input, output, we're getting them on the graph. You pick an x value, you plug it in, a y value pops out, right? That's a coordinate. You do that all night.
Yeah.
Right? So what about intercepts? What the heck is an intercept?
Where they call it.
Where is the graph, or
Where's
the
the
graph line crosses?
Intercepts. Yeah, okay, so I'm going to probably call them curves if I remember. So the intercepts are where the curve, oh, there's one other thing. The where makes me think of one other thing. Where the curve or line, whatever it may be, crosses one of the axes. Is axes spelled the same as axis? How do you spell axes? No.
I'm not very good at English.
All right. Well,
It's
I know what it's not. It's not axes, right?
I feel like it's axes is like possibly ideas.
I feel like I wanted to go that route, but I don't think that's right. I almost put it on there.
I'll look it up.
Yeah, look it up.
I think it's just the same.
I feel I don't know. So we'll find out. All right. So then let's come up with a function. Is this the same?
I think so.
Okay. It's a context issue. All right. So like let's look at. Well, I'm going to do number 16 here.
I mean, if you typed it in, how would you even type it in?
Because you're saying like if you can't spell it right, like how does it?
Yeah, so we're gonna be like, how do you say it? Axis,
Well, I guess you could do what's plural of axis.
I guess.
All right, so if we want to find, if this is true, the intercepts are where the curve crosses one of the axes, how do you find them? Well, if you're, okay, so you can graph them. That's actually what you're going to do on that third section.
Set y or x equal to 0.
All right, so which one is which? That's right, which one is which? So let's do for the y-intercept,
Y is 0. What?
x equals 0, thank you. So set x equal to 0 and solve for y.
9.
So in this case, yeah. Oops.
Yeah.
So right, in this case, yeah. So for the y-intercept for this one, right, set x equal to 0. So then 9. So again, this is a coordinate, right? 0, 9. All right, so yeah, so what about the x-intercept?
Y equals 0.
Thank you. Set y equal to 0. Solve for x. Close. Just as close and just as correct.
Well, it can be both, because you had square root, so it's negative and positive.
Thank you. Very good. Very good. Right. So we add x squared to the other side. Right. We're looking for two answers. That's what that means. So then x equals positive and negative 3. So could you have, obviously you can have two x-intercepts. Can you have more than two x-intercepts?
Yeah.
Yeah. Is there a limit on how many x-intercepts you could have? No, there's no
You
limit.
just go
Not
like
two
this.
that are the same, you're fine.
Yeah, so then can you have more than one y-intercept?
No,
Why?
because it won't pass the vertical line.
Because then it wouldn't pass the vertical line test. Or like that x would have two y values, which is a no-no. Okay, is that okay? All right, so one part I skipped in the introduction ends up being like the hard part. And so this is very important. I want you guys to make sure you know this. I'll let you put it in red here, or if I can touch it. All right. So a lot of times you're going to be asked about where something is happening. So, and this is the hard part because you're switching back and forth between the X's and the Y's. If you are asked where, then you're talking about the X values. If you're talking about it or the function, then you're talking about the Y values. This is very, very, very important. This is like the most confusing part that people have. Okay?
Why is that?
Why is it confusing?
No,
Or-
why is it just that way, just how it is?
So basically the reason is you refer to where because the inputs are very, very boring. They're all just sitting there on the x-axis. And then when you plug them into the rule, something happens to them. They go up or they go down or they stay where they're at. So the interesting thing isn't the inputs because they're always 1, 2, 3, 4, or whatever. The interesting thing is what the function does to those inputs. So when I say, what is it doing? You look at the y values. If I say, where is it doing this? Then you look at the x values. So let's go through a very simple one. We'll bring that one back up that we had. Again, that's where most people get like a little lost when they're talking about functions. So we had something like this. And I don't know, but let's pretend that this value is -2, and we'll put this one as 5. Okay, and then of course there's arrows. All right, so if the question is, where is the function positive? Okay, there's two things going on. I'm asking you for x values, but then I said the function is positive. So then I'm talking about the positive y values. So you have to answer this question by giving me x values. So again, where is this where is this function positive?
Either greater than 0.
Close. What'd you say?
-2.
Anything bigger than -2. So it is positive where x is greater than -2. Okay, so positive, and this is what, again, this is where it gets mixed up, kind of confusing. Anything positive is above the x-axis. So all of this is positive. Where is it positive? As long as it's going bigger than -2. Is that okay? All right. As x gets really, really, really big, what is the function doing?
Longer.
Like, where is it heading? So as I go out here, as x gets super, super big, the function is getting bigger and bigger and bigger and bigger.
Yes.
All right, we're going to spend time looking at that. That's called end behavior. Okay, and that's going to be important. Okay, so as y goes very far to the negative, what is y doing? Going down, so going very far to the negative also. Okay, so that's end behavior. Where, think of x values, what or it or the function is y values. Is that okay? All right, so far we're so good. Right, 13 to 19, that's just calculator stuff, so we got one more thing to look at. What page it is. There's this. Oh, is it? I don't even have it on. I cut it off. There's this, test for symmetry. All right? So you're going to be asked, when we get to the quiz, you're going to be asked to test for symmetry, okay? So you should read this, but I'm going to do a problem that shows you what to do. And I'll do one of your problems. So I'm looking at 21. I'm looking at 21. And what was that? X squared minus y equals 0. And the question is this symmetric about the y-axis? Is this symmetric about the x-axis? Is this symmetric about the origin? All right, so let's start with the y-axis. If the x value sign changes, the y should stay the same. So then the test says, okay, then plug in negative x instead of positive x. and simplify as far as you can. So when you square a negative, what happens? So then when we plug in negative x, it into the x squared, it becomes positive x squared. So now what you do with the test is say, is the original and what I just did the same?
No, you keep the x squared.
Huh? What do you mean, how did I keep the x squared?
Because then you just square the x. No.
Right, because so
Yeah,
so right, if we change just the x
yeah.
and things come out the same, then we're saying, okay, then the y was the same. And so then this is indeed symmetric about the y-intercept. Okay, so same, yes.
Yes.
So symmetric about the y-axis.
So then, if you get a change in so if you could change it, then your x would be changing, so you'd have to do the same thing with this, but with y.
So, okay, so now we're going to, yeah, correct. That's exactly right. So now we're going to check over the x-axis. So instead of substituting the x in, because when it's reflected over the x-axis, the x's stay the same, now we're going to test with the y. Okay, good. Very good. All right, so then I'll scroll this down a little bit. X squared minus y. All right, so like you said, now we're going to test whether it's symmetric about the x-axis. And so then we're substituting in negative y. If it is, then it's going to give us the same equation. But this one, right, a negative times a negative is a positive. So is it the same?
No.
Not the same.
So it means it's less symmetrical on the y-axis.
So this one only is telling us not the same, so not symmetric about the x-axis. Is that okay?
Probably not the same though. Oh, because it's minus.
Because it says y squared minus y, but when we evaluate it, it's y squared plus y now.
So I do like something negative of whatever you're trying to find.
So, yeah, basically, right? So like when you're trying to find, well, I guess it's the opposite, right? So when you're trying to find, because this one was about the x-axis, so then we had to plug in negative for y, yeah. Okay?
So then if you get both changing and be,
Over the origin. So yeah, we'll do it one more time.
Right.
Okay? We'll do it one more time. So again, it was x squared minus y equals 0. So then we plug in negative x here, square it, negative y here. Right, that becomes x squared, but then this becomes positive y. So not the same.
Could use
So
both symmetrical under y and your x-axis wouldn't just be symmetrical on the origin.
I don't think that's true. But it might be. You can investigate and let us know.
It should be, yeah.
I just know that I do one thing at a time. Is that right? All right, that's it. That's all, everything. All right, so then the assignment is 1 to 37 odd.
No, crap. 37.
Oh, I know, it's all of 17 problems or whatever. I mean, God. Yeah, I know. But like I say, like to other classes, if you're not going to do any, why does it matter how many I give you, right? Yeah, so.
Yeah, later if you have no